Hello everyone, welcome to Maths Decoded. Today I'm solving 9709 May June 2021 paper 4-3, which is basically your mechanics paper. So let's get started off with question number 1. It reads particle P of mass 0.4 kg and Q of mass 0.5 kg are free to move on a smooth horizontal plane. Smooth means that there is no friction on the plane, and it's always better if you can draw out diagrams in paper 4. So that's what I'm just going to do over here. This is particle P and this is going to be particle Q. It says that they are moving directly towards each other with speeds 2.5 meters per second and 1.5. So I'm just going to write that down, which is this is 2.5 and this is 1.5, and they're moving towards each other, which means that they're moving like this or they're moving like this. After P and Q collide, so this is basically after collision, and the sentence before this was discussing something about before collision. I can just write it down over here. Before collision, after collision. The speed of Q is twice the speed of P. So let's say if P is X, then Q is going to be 2X. Now, this is a question that is related to the topic of momentum. And in momentum, you need to understand one thing, that you have the authority to state which direction you're taking as positive. I'm going to be taking the right direction as positive in this particular question. It says find the two possible values of the speed of p after the collision. In a momentum question, you need to understand when the particles are moving towards each other, they're either going to start going in the same direction, or they're going to start moving in opposite directions. The third possibility is also that they both come at rest, but that's not an option in this question because they're saying that they are moving after the collision. So we won't be taking the third possibility into account. We'll go with these two possibilities. And we know that they both cannot be traveling this way. Why? Because we're going to be taking the direction of the particle that has a higher speed. Higher speed is of particle P, and particle P is moving right ways. So we're going to be taking the right ways direction. Anyways, first I'm going to label this case 1 and this is going to be case 2. So first I'm going to be solving case number 1. So I'll say 0.4 into 2.5 plus 0.5 into negative 1.5. I've taken this to be negative because this is moving left. If right is positive, then left is going to be negative. This is going to be giving me the momentum before collision, which is going to be 0.25. Now I'm going to calculate this possibility. It's going to be 0.4 into x plus 0.5 into 2x. This comes out to be 1.4x. You know that the momentum before collision is equal to the momentum after collision. So I'm just going to put these two equal to each other. 1.4x, sorry, it's going to be 0.25 is equal to 1.4x. So x over here is going to be coming out as 5 by 28. Now I'm going to be solving this possibility. So I'm going to say 0.4 into negative x. I've taken negative x because this particle P is moving leftwards now. Plus 0.5 into 2x. 2x is positive because Q is moving right. And this is going to be equal to 0.6x. Again, momentum before collision equals the momentum after collision. So that's going to be 0.6x is equal to 0.25. And that is going to become 5 by 12. So these are your two answers. And for anyone confused, the formula that I've basically used over here is m1 u1 plus m2 u2 is equal to the momentum after collision, that is m1 v1 plus m2 v2. Alright, moving on to question number 2. It says that a cyclist traveling along a straight horizontal road, she is working at a constant rate of 150 watts. This basically means that the power is 150. At an instant when her speed is 4, her acceleration is 0.25. The resistance to motion is 20 Newton. Resistance to motion is always going to be in the direction that is opposite to motion. Part A says find the total mass of the cyclist and her bicycle. So again, you're going to be graphing out this scenario because it makes the entire scenario much easier. So you can say that this is the cyclist, and you can say that if she's moving in this direction, the resistance to motion is going to be in this direction, and that is 20 newtons. Now, we know a formula that is power is equal to driving force into velocity. We've been given the velocity as 150. You can divide it by the velocity, that is 4, and that is going to be 37.5. So 37.5 is your driving force, which means the force acting over here. So that is going to be 37.5. Now I'm going to use the formula F is equal to ma. F is basically the resultant force. So that's going to be 37.5 minus 20 is equal to the mass. Mass is something that we have to find out into the acceleration that is given to us in the question, and mass comes out to be 70 kg. Right, moving on to part B. A cyclist comes to a straight hill inclined at an angle theta above the horizontal. So it's an inclined plane now. She ascends the hill. Ascends means that she's going upwards. I'm just going to draw this out again. So there's theta, and it says that she's ascending the hill. That means that she's going up in this direction at constant speed 3 meters per second. She continues to work at the same rate as before, and the resistance is also unchanged. The resistance is unchanged, and the rate is also the same, which means power is the same. That's 150 watts. And resistance force is also the same, that is 20 newtons. It says find the value of theta. So if I try to do this, first of all, I know that the mass I found in the part above was 70 kg. This force over here is going to be acting in this direction, and that's going to be 700. Actually, we can write 70 into g into cos theta. And then you're going to have another direction, another force acting in this direction. That's going to be 70 into g into sine theta. It tells you that the resistance, it's moving in this direction. It means that the resistance to force is in this direction. That's 20 newtons. And apart from that, we need to figure out the driving force. So for the driving force, we'll use the formula again. Power is equal to driving force into velocity. The force is basically going to be 150 divided by 3, because 3 is the speed that they've given us in the question. And this gives us a driving force as 50 newtons. It means that this value over here is 50 newtons. Now I'm simply going to say, because the upward force, it says there's a constant speed. A constant speed means that the forces acting towards the front are equal to the forces acting towards the back. So that's going to be 50 newton is equal to 700 sine theta plus 20. I've put this equal to these two forces, and g I've taken to be 10. In mechanics, you're always going to be taking g as 10. Anyway, so when I solve this further, it's going to be 700 sine theta is equal to 30, and theta, if you solve it, it's going to be coming out to be 2.5 degrees. All right, moving on to question number 3. This is a question about coplanar forces. And in this question, the main trick is drawing your own diagram, because it's going to help you solve the question, as you're going to be breaking down the components of every force. I'm going to be using a different color for every force, so it's easier for you to understand. First, let's have a look at this one. Let me mark this point. Now, this is going to be having two components. Remember that the force component with the angle is always going to be a cos. So this is going to be 20 cos 60, and the one that is not with the angle is going to be 20 sine 60. Now let's have a look at this. So you can see this angle is with, this component of force is with the angle, so that's going to be 30 cos alpha and 30 sine alpha. Now let's have a look at this one. This is going to be F sine theta, F cos theta. And last one, 40 cos beta and 40 sine beta. So before I move any further, first we need to find out the angles as well. If they've given you sine alpha as 0.28, you're basically going to take out the sine inverse, figure out a value for alpha, and then you're going to put it into cos, and that's going to give you cos alpha as 0.96 and this cos beta as 0.8. Now I'm going to be solving the um, vertical components first. That's going to be f sine theta plus 20 sine 60. That's equal to 40 sine beta plus 30 sine alpha. If I just plug in the values, that's going to be 20 into sine 60. This comes out to be 10 square root 3. 40 into sine beta, that's 0.6, plus 30 into sine alpha, that's 0.28. This is going to come out as f sine theta plus 10 square root 3 is equal to 2.4 plus 8.4, and that is going to give me f sine theta is equal to 15.0794. Now let's solve the horizontal components. So that is going to be 20 cos 60 plus 30 cos alpha is equal to f cos theta plus 40 cos beta. If I solve this further, that is going this is going to come out as 10 plus 28.8 is equal to f cos theta plus if I plug in cos beta is 0.8. So if I plug that in, that's going to be 32. So f cos theta is going to be 6.8. Now I can make f the substitute the formula in both of these cases and over here as well. Now I'll put f equal to each other. I will equate both of these values. That's going to be 15.0794 divided by sine theta is equal to 6.8 divided by cos theta. If I further solve it, I'm going to multiply, cross multiply. I'm going to solve it in such a way that I am able to turn sine theta over cos theta is equal to tan theta. This is an identity that we do in trigonometry if you don't know. So let's say I put sine theta over cos theta is going to be equal to 15.0794 divided by 6.8. And that is basically going to give me tan theta is equal to 15.0794 divided by 6.8, and theta is going to be coming out as 65.7 when you put it into a calculator. Also remember that your angles are always supposed to be one decimal place, rounded off to one decimal place. Anyways, we have to find the value of f as well, so I'm going to be plugging it back into this cos of 65.7. That is going to give me f as 16.5. All right, moving on to question number 4. It says a particle is projected vertically upward. So it's a question about kinematics, I'm assuming. With speed u from a point on horizontal ground after 2 seconds, t is equal to 2. That means the height of the particle above the ground is 24. So s is 24. It says that show that u is equal to 22. So you're going to be using the simplest Stewart equation, that is s is equal to ut plus half at squared. We know s is equal to 24. Um, and u is something you have to find out. Time is 2, so 2u plus half. A is minus 10 and t is 2 squared, so that is 4. That's basically going to become, if I simplify that, this is going to come like minus 5, and that's leaving me with 44 is equal to 2u. U is going to become 22. Acha. Moving on, it says the height of the particle above the ground is more than h meter for a period of 3.6 seconds. So again, it's better if you graph it out. I'll draw a horizontal ground. It says that the ball is over here first when and the initial speed is 22. Let's say that this is height h, and it says that it's going like this, and then it's coming back like this. So it's basically in this portion for a period of 3.6 seconds. That means that it goes up and takes 1.8 seconds, then it comes down, it takes 1.8 seconds. Um, so if I know that, if I could figure out the total time from this point to this point, that would help me out. So let's find out the total time. The total time is going to be, I have u is equal to 22. It's always better if you write down the variables that are given to you. It's going to, prevent confusion. And a is minus 10. So I'll basically say v is equal to u plus 80. That's the best equation over here. V is 0. And I've taken v to be 0 because we're calculating the time that it takes from go to here to here. And the speed at your maximum point is always going to be 0. So that's why v is 0. U is 22, a is minus 10, and t is something we're trying to find. If you solve for this equation, that's going to be 2.2 seconds. That means you're going to be subtracting 2.2 from 1.8, and that will give you that it takes 0.4 seconds to travel um, till h, because it takes 2.2 to do this entire distance, 1.8 for this distance. So I subtract both of them, and I will get the answer as 0.4 for this part. I hope that makes sense. Anyways, now I can say that u is equal to 22, t is equal to 0.4 as we figured out, and acceleration is equal to minus 10. So I can figure out s, which is basically h. S is equal to ut plus half a t square, 0.4 square. That's going to give me s is equal to 8.8 plus minus 0.8, and that is going to be 8 meters. Alright, moving on to question number 5. It says a car of mass 1400 kg is towing a trailer of mass 500 kg. Again, a question from connected particles. So like I said before, it's better that you draw a diagram. We're going to be drawing a diagram over here. So 5 degree is the angle at which it's inclined. It says that there's a car of mass 1400 kg, and towing means that they are connected. And then it is connected to a trailer of mass 500 kg. Down a straight hill inclined at an angle of 5 degrees to the horizontal, the car and trailer are connected by a light rigid tow bar that I've already made over here. At the top of the hill, the speed of the car and the trailer is 20. So I can write u is equal to 20. And at the bottom of the hill, their speed is 30. That means v is equal to 30. Sorry. Then it says it is given that as the car and the trailer descend the hill, it means they're moving like this. The engine of the car does 150,000 joules of work, and there are no resistance forces. Find the length of the hill. They want you to figure out this entire length. And I think that let's label it L. I think that we'll have to employ some bit of trigonometry in the last few steps. And to do that, we need to be knowing this length. So let's work on finding this length first. Let's label it h. First of all, I know that because it's moving from top to bottom, there's going to be a loss in potential energy, because when you decrease in height, there's a decrease in potential energy. So let's calculate the change in potential energy. That's going to be mgh is the formula. M over here is going to be 1400 plus 500 because they are connected particles, so it's going to be taking the mass of both of them. G is 10 and h is what we're looking for. This gives you an expression 19,000 h. Now we're going to figure out the change in kinetic energy. You know that the kinetic energy is also changing as all that is in motion now. The kinetic energy is basically going to be increasing because over here it was at rest, and the kinetic energy is something that is also going to be changing. So that's half mv squared. That's going to come half. M over here is going to be 1900. And so what was the initial? The initial was 20 and the final is 30. So we do final minus initial. That's 30 squared minus 20 squared. And that's going to give you an expression 475,000. Now you need to understand that because you're gaining kinetic energy, so a gain in kinetic energy, gained kinetic energy is going to be equal to the loss in potential energy plus the work done against resistance, which is actually given to you in the question. Not resistance by the engine, because there were no resistance forces. So if I just write that down, that's going to be 475,000 is equal to 19,000 H plus 150,000 as given to us in the question. If I solve, the H is going to be coming out as 17.105. All right, now here's the situation. This is 5 degree. This is 17.105, and they want you to figure out this. If you use SOHCAHTOA, you'll be able to see that we will be using sine over here. So sine 5 is equal to 17.105 divided by h. H is going to come out as 196. So it says that it's given that there is a resistance force of 100 Newton on the trailer, the length of the hill is 200 meter, and the acceleration of the car and trailer is constant. Um, Now, in the previous part, they told you that there is no resistance, but now we do have a resistance, but it's just on the trailer. And the length is also given to you in this question. Again, I'm going to make a diagram for this. This is 5 degree. This is your 1400 engine with your 500 trailer. But they're moving like this. It means resistance force is going to act here of 100 Newton. You know that there's going to be a tension over here and a tension over here. And this is going to be 500 cos, actually it's going to be 5,000 because it gets multiplied with g, and actually we don't even need the vertical component, we only need the horizontal component. That's going to be 5,000 cos sine theta, sine 5. And for this as well, it's going to be 14,000 sine 5. All right, so we know that u is equal to 20 and v is equal to 30. Over here we can just use the SUAT equation, v square equals u square plus 2as, to figure out your acceleration. Because to figure out the new tension, we need to figure out the new acceleration as well. Why is it a different acceleration? It's a different acceleration because now you have a resistance force as well, unlike the first part. So that's going to be 30 square minus 20 square divided by 2 into s. S is also given to you, 200. And that is going to give you acceleration as 1.25. Now I'm going to make an F is equal to ma equation. F is equal to ma. I'm going to take the resultant force on the trailer because that is where your resistance force is also going to come into account. That's going to be 5,000 sine 5 plus P, which is the tension, this one is minus 100 which is your resistance force, is equal to mass, that's 500 into 1.25. If you solve this, I'm going to be skipping the solving part. If you solve this, it's going to come out to 89 newtons. So we're going to put 2t square minus 5t plus 3 equal to 0. I'm going to be using middle term breaking. You can use quadratic formula. You can use your calculator, directly put into your calculator. But basically, you have to show the working. You can't directly write down the answer, you won't get the marks. So I'll basically say minus 3t minus 2t plus 3 equals 0. I'll take t common out. That's going to become 2t minus 3 minus 1, 2t minus 3 is equal to 0 minus 2t plus. All right. So I'll write it down as 2t minus 3 and t minus 1. That is going to give me t is equal to 1 and t is equal to 1.5. Now, what does this actually mean? I know that this is a quadratic equation, and a quadratic equation with a positive coefficient over here, it means that it's something like this. I know that the y-intercept is 3. It's always going to be easier for you to solve these kind of questions that involve variable acceleration if you make a graph on the side of your page. Um, and then it says find the minimum velocity of the particle. What is the minimum velocity? This represents time, this represents velocity. The minimum velocity is at this point. How am I going to find this point? Maybe if I know the x coordinate at this point, I will input it into the equation and figure out this point. So how am I going to find this? I'm basically going to say 1 plus 1.5 divided by 2. That is going to give me 1.25. It basically means that this point over here has a x coordinate 1.25. And now I'll import 1.25 back into the equation. That is going to be 1.25 squared minus 5 into 1.25 plus 3. So the velocity will come out to be v is equal to minus 1 by 8. Okay, all right. Next part says sketch the velocity time graph for the first few seconds of the motion. We already did this, but now I'm going to do it again. Um, we know the y-intercept is 3. Let me mark that. Remember to make sure that you mark the axes. That's v ms minus 1. I know that this is 1, this is 1.5. These are the roots that we found in the first part. Uh, they want you to find out the velocity till 3 seconds. So you need to be knowing this. This is 3 seconds. You need to be knowing the y coordinate at this point. To figure that out, I will plug in 3 into this equation that was given to us. That is going to be 6. So mark this as 6. And apart from that, I guess you could also mark the minimum velocity, that is negative 0.125 and 1.25 as well. All right, moving on to part C, it says find the distance traveled between the two times when the particle is instantaneously at rest. These two times we've already figured out in the parts above, that's t is equal to 1 and t is equal to 1.5. There's a very simple trick that I have made myself to help you solve these questions. It basically is don't drop very dangerous appliances. This is a mnemonic that I have made to help you remember. So hear me out. Don't drop very dangerous appliances. This is distance, this is velocity, and this is acceleration. So whenever you have to go from distance to velocity, you will differentiate. Velocity acceleration, you will differentiate. But if you have to go the other way around, it's pretty obvious that you will have to be integrating. So this basically helps you remember uh, this concept in a crux, I would say. So basically, the equation that was given to us was a velocity equation, if I'm not wrong. Yeah, 2t square minus 5t plus 3. This was the equation that was given to us. I want to turn this into a distance equation because the question asks for distance. So if I'm going from velocity to distance, I'll have to integrate. If I was going from distance to velocity, I would differentiate. But in this case, I'm going from velocity to distance, so I'm going to integrate this. So let's see. That's basically going to be integral of 2t square minus 5t plus 3. I'll put the limits as 1.5 and 1. Now, there's one thing you need to understand that this area is under the x-axis, and whenever you take the area under the x-axis, it is going to be negative, and you don't want your distance to be negative, so you will automatically put a negative sign. Basically, whenever your area that you are covering, whenever the limits that you are covering are below the x-axis, you are going to put a negative sign automatically over here because your answer will become negative. So a negative and negative will then make positive. Anyways, so let me integrate this. When you integrate this, it becomes 2 over 3 t cube minus 5 over 2 t square plus 3t. Limits are 1.5 and 1. So first I'll plug 1.5 over here. Then I'll plug 1. So this entire thing minus 2 over 3 1 cube minus 5 over 2 1 plus 3 into 1. And if you subtract this and solve it, it should be coming out as negative 0.417. Now remember, I put a negative sign over here, so it's going to become negative into negative 0.417. That will become positive 0.417. This is the reason why I told you to put a negative sign over here. Also, one very important thing in mechanics, when you're writing down the answer, if it says find the distance, you will be putting meter over here. I mean to say that you will be putting the unit over here. But if it said find the value of the distance, then you're not going to be putting m. You're not going to be putting m in that case. I hope that makes sense. All right, now question number 7 reads a particle p of mass 0.3 kg rests on a rough plane, means friction exists. Whenever it will say that it's a smooth plane, that means there is no friction, but when it says rough, it means that friction is present. Inclined at an angle theta to the horizontal, with sine theta is equal to 7 by 25. A horizontal force of magnitude 4 Newton is acting in the vertical plane containing a line of greatest slope of the plane is applied to P. So it means that 4 Newton is basically acting somewhere like this. No, actually, it means that this is the 4 Newton that they're talking about. Particle is on the point of sliding up the plane. Show that the coefficient of friction between the particle and the plane is 3 by 4. Alright, first things first, we need to mark the component of the forces. That's going to be 3 into 10, that's 30. Cos theta and 3 sine theta. Also that it says that it's moving up the plane, which means that friction is going to be acting in this direction. And there's a normal contact force, which is R, and that's pretty much it about it actually. So you're going to be saying that, um, oh no, wait, one more thing. So you have the 4 Newton force, you also have to integrate that. That is going to be 4 sine theta in this case, and 4 cos theta in this case. All right, now let's start solving. So I'll put the horizontal forces first. F plus 3 sine theta is equal to 4 cos theta. Now they have given you sine theta. Again, as I told you earlier in the video, you will have to figure out a value for theta by doing sine inverse of 7 divided by 25. Then you'll put the answer into cos and you'll get a value for cos theta as well, which in this case is going to be 0.96. Anyways, now I will do f plus 3 into sine theta, that's 7 by 25, is equal to 4 into cos theta, that's 0.96. That is going to give me f is equal to 3. Then let's figure out a value for r. r is going to be, r is equal to 4 sine theta plus 30 cos theta. R is going to be equal to 4 into 0.28 plus 30 into 0.96. My bad, it's actually 3, not 30. So R is going to be equal to 4. Now you'll use the formula F is equal to mu R. Mu is what basically the coefficient of friction that they want you to calculate, and they want you to show that it's 3 by 4, and so F is 3 and R is 4. So mu is going to be 3 by 4, hence proven. Alright, now it says the force acting horizontally, which means this force, is replaced by a force of magnitude 4 Newton acting up the plane parallel to the line of greatest slope. It basically means that this 4 Newton force is removed. That means actually it's better that if I make a diagram myself, that's going to be much easier for you to understand. Now we need to understand that no matter whatever changes they make, the coefficient of friction is always going to be a constant. So the mu over here is also going to be 3 by 4. I also know that the r in this case is 3 cos theta. R is equal to 3 cos theta. Cos theta is 0.96, so R is 3 into 0.96. Uh, Now let's calculate F. F is equal to mu R. F is going to be equal to mu, that's 3 by 4, into 3 into 0.96. That is going to become 2.16. So we have the friction figured out. Now I'm going to be using F is equal to ma. So let's calculate the resultant force. The resultant force is going to be 4, which is this, minus the friction minus this. Let's do that. 4 minus 3, I think, sine theta. Sine theta is 0.28. Uh, Minus the friction, that's 2.16, is equal to the mass, which is 0.3, into the acceleration. Acceleration is something we have to find. That leaves you with 1 minus 0.3a is equal to 0.3a, and a is going to be 10 by 3. All right, moving on to C part. Let's have starting with P at rest. The force of 4 Newton parallel to the plane acts for 3 seconds, and then this is also removed. Find the total distance traveled until P comes to rest. So here's how it's working basically. First you had a 4 Newton force acting like this was removed, then a 4 Newton force was applied like this, and now they're saying that this force only acts for 3 seconds, and then this force is also removed, and then the ball basically moves until it comes to rest. So what is the total distance that is traveled in this case, starting from this force? So uh, we know that acceleration that we found out was 10 by 3 in the previous part. U is equal to 0 because it says starting at rest, and time is equal to 3. They gave us the time over here. I use S equals ut plus half at square, ut plus half at square. This is going to become 0 because because u is 0, so half minus 10, no, not minus 10, 10 by 3 actually. T, that is 3 square, so this is going to become 15. This is the distance traveled when the 4 Newton force was applied. Now after this, we'll now calculate it. Now it says that 4 Newton is removed. Now when 4 Newton is removed, one more thing we need to calculate over here before I move on to the other part. We need to calculate the V value. So V is equal to U plus AT. V is equal to 0 plus 10 by 3 into 3. So V is equal to 10. Now, this V value is going to be the U value over here. So U is equal to 10. Acceleration is something we again need to figure out over here. And for that purpose, I will be using F is equal to ma. The force over here is now going to be the same, except that the 4 Newton force is going to be removed. 3 into 0.28 is equal to 0.3, which was the mass, into the acceleration. Basically, what happened was that this 4 Newton force was removed, and I took the resultant force with these two forces over here. Uh, so this is going to give me acceleration as minus 10. I have a u value, I have an a value. I also know that my v is going to be 0 because it's actually in the end it's coming to rest. So again, I use v square equals u square plus 2as. V in this case is 0 square plus u, that's 10 squared, plus 2a over here is minus 10. S is something we need to find out. So S comes out to be 5. Now what's the total distance? First we found it was 15, now it's 5. So 15 plus 5, that equals 20 meters. And with that, we come to the end of this paper. I hope this video was helpful for you.